This is the Unit 7 Study Guide answer key for questions number 20 through 22. For this one, that's going to be a lot of Bohr diagrams. We kind of already did a few of these in the previous video, so I'm going to go sort of fast, but you're going to need your periodic table for these. The difference between this one and the previous one is they're asking us to draw Bohr diagrams for isotopes in these first three boxes, and then they're asking us to draw Lewis dot and Bohr diagram for ions. So there's kind of a little bit of a twist from the last video. So for this first one, it's nickel 58, and remember, when it's written this way, that's a mass number. It means protons. Oh, that means protons plus neutrons. So the atomic number for nickel, all you have to do is look at the periodic table and find Ni, and on the periodic table, Ni is number 28. And the mass number for that one is what it says right after the nickel, so it's going to be 58 for the mass number. For protons, it's going to have 28 because it's the same as the atomic number. Electrons, we're assuming neutral, remember from the instructions, so also 28 because all the pluses have to balance out the minuses. And then for the neutrons, we have to do a little subtraction. We have to take the atomic number and subtract it from the mass number, which was where it says nickel 58. So 58 minus 28, we're looking at 30 neutrons. Now I've got a tiny space and I'm working with this digital pen, so bear with me if it's messy. But in this little drawing, we're going to be putting, first of all, the symbol. So Ni is nickel. We also need the amount of protons and neutrons down here. So protons, we figured out, was 28, and neutrons was 30. Now I'm going to pick a different color for my shells. You don't have to, but just to keep things not messy, again, I stay away from the dots because it's easier to write the numbers, it's easier to read somebody else's work when they haven't used dots, but technically either way is fine. So nickel's going to have a lot of shells. If you're looking on the periodic table, it's in the fourth row on the periodic table. So we know automatically that it's going to have 4 shells. But I'm going to go kind of one shell at a time and reason it out. So we know that the first shell is going to have 2. The next shell out is going to have 8. We're up to 10. The next one after that is also going to have 8. We're up to 18. And then the final shell is going to have 10. And the reason why I knew that so quickly is because when I'm looking at the periodic table, I know that nickel's in the 4th row. That told me 4 rings. But I also count over. And if I'm counting over from potassium, that's K on your periodic table, I count over and it's the 10th one in. That tells me it's going to have 10, but you can also add these up. We should end up with 28 because it's going to be neutral, so we've got 2 plus 8 is 10, plus 18, plus 8 is 18, plus another 10 is 28, and we've got our total thing. As far as the last step, you're probably, oh, I'm so messy with this thing, you're probably going to want to put in your rings around like this, but honestly, it's just kind of picky. Doesn't really matter that much. But there is my messy nickel Bohr diagram. For the next one over, we've got potassium. Potassium is number 39, or excuse me, potassium his isotope is mass number of 39. So I've got to find potassium on the periodic table, and it's number 19, so 19, not 39. Number 19 on the periodic table, so it's got 19 protons. I'll put that in right here. Its mass number is 39 because that's what the isotope number tells us. It's going to also have 19 electrons and 20 neutrons because I did 39 minus 19. So now to make my Bohr diagram, potassium is a K, protons are 19, neutrons we said were 20. And now for my rings, again I'm going to go kind of quick. So we've got potassium in the 4th ring, first column, or 4th row, first column, so it's going to have 4 rings, so I know the first ones have to be full. 2, 8, 8, and then it's in the first column, or excuse me, keep messing up. Yeah, first column, so it's going to have 1 electron in its outer ring. So it's going to go 2, 8, 8, 1, and just to make sure, 2 and 8 is 10, plus 8 is 18, 19, and it does indeed actually add up to my protons. You could add in your rings around that, and probably you should, but I'm running out of space, time, and I'm working with a digital pen. So the last one is neon. Neon is number 10 on the periodic table, so I'm automatically going to go 10 for the atomic number and protons. Because this isotope is neon 21, that means the mass number is 21. It's going to have the same amount of protons as electrons. For the neutrons, I've got to do my mass number minus atomic number, so that's going to give me 11. And now I can start my Bohr diagram. protons, neutrons. Protons we said were 10, neutrons we said were 11. For the rings, again, I can look at my periodic table and notice that neon is in the second row, so it's going to have 2 rings. So I know I can fill in that first one automatically as a 2. That one's full. And then it's in the 8th because there's no elements in between beryllium and boron. It's in the 8th box from the left, so it's going to have 8 in its last shell, and just to make sure, it should have 10. So we've got 2 plus 8, we're good. And you can, of course, make your rings to finish that out. For the next one, number 21, we're supposed to draw a Bohr model and a Lewis model for sodium with a 1 plus. So we're talking an ion now. So I'm going to start with the Bohr model and go real fast. So sodium is going to be Na, protons, neutrons. When you look on the periodic table, sodium has 11 protons because it's number 11. And when we look at its atomic mass, it rounds to 23. And so that means that 23 minus 11, it's going to have 12 neutrons. So, didn't mean to cross right through there. That means that we're going to have that for our messy nucleus. I'm kind of working backwards with my colors here. So it's going to have 11 electrons normally, but it says with a 1 plus charge. So that means that it's going to have 1 fewer electrons. I know it's a little bit hard to get your brain around, but this means less 1 electron. So again, normally it would have 11 since its protons are 11, but we've got to go 10 in order to get that plus 1 charge. So 2 in the first shell, 8 in the next. That'll give us our 10, and if you were to wrap your rings all the way around, you could, but I'm pressed for space. So now we got to do the Lewis dot model, and I love doing Lewis dot models over Bohr because they're so much easier. So we just go Na, and because if you're looking at the Bohr diagram, the Lewis model shows the outer ring. So usually we would go Na with a single dot, but this is Na with a charge. So let me get rid of that. Na with a plus 1, that means that the next layer, this one with 8 in it, that's the one that's exposed. So I've got to go 8 dots in order to show Na with a plus 1 charge. Number 22 says draw the same models as we did in the last one, but this time for a silicon with a 4 minus. So that 4 minus is going to tell us add 4 electrons. Okay, so I'm going to start over with my Bohr diagram, and we're going to go Si at the top. Looking on the periodic table, silicon is number 14, so it's going to have 14 protons. And when I look at the atomic mass, it says 28.09. When I round it, I've got to take 28 minus 14. That means 14 neutrons. So I've got my, I did it again. I've got my nucleus. Now I've got to start on the rings. So again, we've got to be really careful because this is an ion, so we've got a different amount of electrons than normal. Usually silicon would have 14 electrons in order to make it neutral, but we just said a minute ago that we've got to add 4 electrons. So it's going to have 18 electrons. So that means that I'm good putting in my 2 in the first ring, my 8 in the next. That gives me 10. And I have 8 more to place. Well, that's exactly how much can fit in the next ring. So it's going to be 2, 8, 8. And just to be sure, 2 and 8 is 10, plus 8 is 18. We're good by adding 4 to that 14. Now the Lewis model. Lewis model is so much easier. Silicon, and because we added 4 electrons, usually silicon would have 1, 2, 3, 4 electrons. But because we're talking about a silicon with a 4 minus, we've got to add 4 more. So it's going to have a total of 8 dots around it.